Hey guys, my name is Anurag Gupta. I'm a program manager on the Operations Management Suite team, specializing in log analytics and Linux, specifically for the log analytics. So today I'm going to talk to you about monitoring Linux in any cloud with Operations Management Suite. Any cloud means Azure, it means AWS, it means you're on-prem, it means wherever you can get Linux running, we can monitor it. Now I got two fun live demos during this session that it has audience participation. And the first one I need your help is, are you on Twitter? And if you are, can you tweet hashtag MSOMS? I just need one or two people to do it. If anyone has a Twitter account they want to tweet to, I can do it myself if no one else. We got one over there. Perfect. Okay, I need you to tweet, and it's showcasing some of the custom data we can monitor and expose inside of log analytics, showing how you can get almost any data, any type of data within the log analytics platform. Perfect. Now I have a pretty quick agenda, right? Monitoring Linux in any cloud. I'm going to talk a lot about monitoring. I'll give you a lot of demos. We're going to first, though, go through an introduction about Microsoft plus Linux. There's another session going on right now about Microsoft loves Linux. And I'll showcase some of that here as well, and then show you how that roadmap affects you as, say, a sysadmin or someone who's doing data analytics on large platforms, and then talk about monitoring in 4 different aspects. First being the core metrics and logs, the operating system, the configuration and updates. How do you use monitoring to then go into a diagnosis? And then application data, right? The whole reason you're using Linux is because you're running your workloads on there. And how do you start monitoring those workloads? Lastly, you saw the tweets that I asked you to send. Thank you very much, is for the custom data. Everyone has their own needs, own metrics, own logs. How do you get that stuff going inside of log analytics? And how do you monitor that at scale? Last, I'll open up the floor for Q&A. And I also got some fun stickers here. I got some Microsoft Loves Linux, as well as some log analytics specific stickers. So feel free to come by afterwards and pick some of those up. So the Microsoft plus Linux story, right? When you talk about Microsoft monitoring Linux, that was our first foray into this brave new world. In 2009, we introduced support for Unix and Linux management packs with System Center. Then, going down the road, we actually found out that, hey, we're going to do some of this virtualization stuff with Hyper-V. And then day one on Azure, we introduced Linux VMs. And within the past year and a half, we've started to double down on those Linux efforts and keep on going, start delivering our core application sets, SQL Server, .NET Core CLR, PowerShell, Microsoft OMS agent on Linux. And what does that mean for you? That means, hey, we're really trying to provide a consistent platform that works across the OS, not try to singularize on Windows. And as you keep on monitoring stuff and learning the Microsoft toolset, we're going to empower you to start managing the whole other side of the data center. The whole other side of the data center that might be on-prem, that might be in the cloud. And if you're doing OMS, all of a sudden now you have the capability to do Azure services, Windows, and Linux, all with the single tool set, all with the single language. So that's our kind of core empowerment there. And just some stats and tweets that kind of showcase, hey, people are noticing that we're doing Linux. In fact, I just saw a great article about, hey, Microsoft really does love Linux. And then, 1 in 3 Azure VMs are Linux. Makes complete business sense for us to continue pursuing that avenue and keep on delivering key value there. So next up, our approach with open source. Right, we have 2 main pieces here. First is the integrations and the collections, the collectors. Right? Our first-party OMS agent is actually something built off of open source. It's built off of this agent called FluentD. And if you haven't heard of FluentD, it's being used all over the place. Google uses it for Kubernetes in their container platform. They also use it for their cloud platform, Stackdriver. We invested in it way before then, so I like to give us a little fist pump. But you can see, hey, we also have integrations with other monitoring tools. So we're not going to try and displace the stuff that you might have in a legacy Linux environment like Nagios and Zabbix, stuff that people have been building out for 15 years and made sure that, hey, it's going to run exactly like this. We want to make sure that we can come over it and add value, give you something so you can win in that Linux world and have the ability to get the data that you need and diagnose the troubles that you might see. Next is the OMS service. And our solution platform handles trillions and trillions of logs and data points so that you can search across it and have the capabilities such as our monitoring, our solution platform, our ability to look at security data, our ability to look at patch data. So under the hood, we're using a lot of open source components, and that matters in two ways. One, if you're utilizing one of these open source platforms yourself, we're actually contributing back. It's a two-way street. In fact, next month we have a conference for Apache Solar about how Microsoft OMS uses that as their log analytics platform and how we've used Solar in one of the largest environments in the world. The second piece is as open source continues to evolve, we'll take in all the new features that people are contributing there that might give you more performance enhancements, as well as introducing new open source. So say there's a new open source big data analytics piece that's going to make things 10 times faster. Our modularized system is going to let you have the same experience for the whole log analytics, but with a whole new thing underneath. So this slide shows the supported Linux distributions for monitoring Linux. I want to take a quick snapshot of that, feel free to go ahead. The big thing here is we're not just doing one Linux OS and saying, we got it, we got Linux, we did it, we're doing this one OS. And we're going after stuff that might even be legacy, such as Red Hat 5, which is an extended Red Hat support right now, not even core maintained. So we're really understanding what enterprises have with all of these different operating systems, and we're also making sure we're keeping up to date. So you can see Core OS there, a whole container-based operating system, as well as the latest Ubuntu 16 version. So a quick overview before we jump into demos is what does the overview of monitoring look like? You can see there's the FluentD agent. This is the first-party agent that we deliver. We first take in existing tool sets like Nagios and Zabbix, so bring those alerts in without deploying to every single box. Metrics, where you have the operating system metrics as well as custom things such as StatsD and CollectD. You have application monitoring. So just a first foray into it, over the past 2-3 months, we've made a MongoDB solution, a MySQL solution, VMware, Docker, as well as security pieces. So AuditD, all the tracks that are going on in the operating system, as well as firewall logs. So you have Cisco, you have Barracuda, you have all of these firewalls that are able to forward their logs to the Linux agent, and we're able to do some really cool security pieces on top of that, telling you which IPs are malicious, which pieces of those are coming from a malicious endpoint. As well as logs, right? Logs are apparent for both applications and just custom logs itself. So you can get your system logs at a very core as well as other application logs. So diving into a quick demo, and just as a quick show of hands, how many of you guys have seen OMS and log analytics? Okay, so like around 90% of the room. So for the 10% that have never come to the OMS portal, this is it. This is the place where you can view everything. And you'll see here I have a bunch of tiles, and what we call these tiles are solutions. And solutions give you an overview of some brief insights, the needles in the haystack of domain-specific problems such as security, or solution-specific problems like Azure Site Recovery. And these are essentially like apps. You can come into a solution gallery and go in and say, hey, I want to go get this solution that helps me look at change tracking, look at patching. And these give you quick insights into what's going on, and they're all powered by this insanely powerful log analytics platform. So at the very core of monitoring is, of course, the OS metrics and the system logs. So what does that look like in log analytics? So here I've jumped into log search, and what I'm going to do is just what Scott Guthrie did in his keynote. I'm just going to search for everything over the whole past day. You see I just grabbed around 19 million results, and I grabbed data from almost everything coming in. And you're going to say, hey, what's the Linux monitoring piece here? Well, the first thing is the Linux data here is in the exact same place as the Windows data. So I'm not saying, oh, give me everything but limit it only to Linux. Give me everything but only limit to Windows. I just said give me every single piece of data. And that is going to give you visibility instantly into the other side of that enterprise, which is using Linux. So now all of a sudden I have all this data in one single place, and now we can start to monitor it in a cohesive way. So let's first jump into performance. So I'm going to go ahead and click into performance. See, if I don't even know the query language, I can just come on the left like a shopping cart and select the filters that I want to go ahead and monitor in. And then let's go ahead and say, let's go and get the processor metrics. So I can come in here, click processor, click apply. And then I can get all of the processor metrics across both Windows and Linux and have the visualizations of what's going on across all of these different counters that apply to a processor. But that's no fun, so let's go ahead and look at a broad scale and see what the average counter value is over the past day, and do that and graph it in a nice visual way such that when someone needs to look at this, they can actually monitor it and watch it and make sure it's not going into a quick craze or heavy delta. So I'm going to type here, get the average value. And I'm going to do that by computer. And then I'm going to bucketize this into intervals of 5 minutes. So now I've gone ahead and graphed this, and you can see all of these different computers have started showing me their average computer value over the past day. And I have some MySQL computers in there, I have some Linux computers in there, and I have some Windows computers in there. So all of these different operating systems giving me that visibility across these core OS metrics and having it in a unified experience so that if I'm doing a calculation and I want to look at just Linux, I can, but I also have the ability to look broadly at all the operating systems that are reporting it. And if I'm going to want to look at this daily and make sure that my performance for this CPU is going well, I can save this query and have it as part of my visualizations on a dashboard. The next thing is logging. So we've given you the ability to look at performance, but hey, if there's a performance spike, what do I do? What do I look at? How do I know what's going on that machine? And that's where the pivotization to syslog is key. So having the ability to get those system logs, we can then go ahead and just say, hey, just give me the syslogs over that same time period. And then I have all of the Linux computers that are reporting syslog coming in. And syslog itself is a flexible platform, right? You can have network devices talking to syslog. You can have Java applications talking to syslog. So you already get this array of different elements that can plug into syslog. So having the ability to quickly tread through that is also really important. And that's where we have platform level features that apply to the data that's coming in here and not necessarily a platform specific data type like Windows or Linux. And that's where we have this nice little thing called Minify. I can easily click this, and while, hey, it would be really fun for the rest of the session, I scroll through the 447,000 results, I can click Minify and get that bucketized into, say, 263 event groups and quickly discern the differences between these logs. Right? So if I have all these Java logs, all these network logs, all these system logs coming in to syslog, I can quickly go into this log analytics piece, group it together based off pattern recognition, and then look at what those differences are and where those differences exist across these multiple groups. And so that at a very core level is what we released last year as part of our private preview for Linux monitoring. And we've built multiple stacks on top of that as to, hey, these are the next pieces of just the core monitoring scenarios. And so building off that core monitoring piece is how do we bring those views into those insight pieces you saw, those solutions you saw, and how do we give you richer monitoring and diagnosis ability? And that comes with configuration and update. So when you look at configuration and monitoring from a configuration perspective, you want to monitor the changes that are happening in your environment. And why do you want to do that? Because if someone's installing something that shouldn't be there, you want to be alerted about it. If someone's updating something and it goes to a version that's too new for another package, you want to be notified about that. Linux daemon changes. How many times has a service just shut down and you're, why is my MySQL not working? Why is my MySQL not working? And it's just because someone just said service MySQL stop. And lastly, you want to have the ability to get visualizations on top so that you can quickly diagnose these service issues. And then update. Update is not generally viewed as something you would want to monitor, but when you take it from a security perspective, it's absolutely something that should be considered. You want to make sure you have the ability to look at what updates are available, and if any of those updates have CVE numbers, vulnerabilities associated with them. So when the next Heartbleed bug comes out, you're not scrambling to figure out what's going on and how to go update. You know, oh, these are the computers that are affected, these are the patches affected, these are the CVE numbers associated with them. And lastly, we've done this so it's a common identifier across Windows and Linux, so that when you are looking either at configurations or updates, you're not trying to figure out which ones are Linux, which ones are Windows. You know which ones are security and critical. And so let's jump into a quick demo of this. So we'll come back to the home screen, and we'll first jump into change tracking. So this solution includes both Windows and Linux, and it tracks changes that are happening in the environment. So at a Windows level, we're looking at the different MSIs that are going on, and at the Linux level, we're looking at the packages both from RPM and Debian. So here I get a nice little graphic about all the changes happening in my environment for Windows services, software that includes both Windows and Linux, daemon changes, so Linux service changes, and the files, the actual content. Now let's scroll over here, and I can see some of the package changes that have happened. I have had 17 package changes in the past 7 days. Oh, also including my OMS agent. So what I could do is go ahead and click down into that. And what this is going to do is it's going to take me straight into log search, the same log search I used to search for syslog, the same log search I used to search for performance, but this time giving me a configuration change. And here I can see I had a version of 239, and now it's coming in at 1.2.0.25. So hey, I've actually updated this agent from a preview version to the actual GA version. So hoorah, that's great. But guess what? Someone told me, hey, there's some error going on, and he's saying, oh, it's because you updated this agent. Well, let me prove him wrong by going in and looking at what is happening during this change. So I'm going to actually come into this changes view. And what this is doing, it's laying over a perspective based off the data returned in search. So because it knows it's a configuration change, it's going to expose this to me. And I now have the ability to drill down into this specific change, this specific block of time, all the way down to, say, the 15-minute mark. Now what I'm going to do is I'm going to go back and say, oh, this is actually happening on the computer on Hagoop Twitter. So I'm going to go ahead and delete this type. I'm going to change it to syslog for that same time. And I'm going to specify that computer for this Twitter computer. OK, so now I have a bunch of stuff. And what I'll do again is click this minify because 562 is still a little too high for me. And I can see, oh, I got 27 event groups over here. And it looks like, hey, you know, there's something going on with the yum update piece, as well as a password check failing for the user root. So maybe someone's attacking my system. I don't know. But having the ability to quickly go from configuration changes to logs and then look at what may be going on is absolutely critical. Now, the next thing, of course, about monitoring is alerting. Is, hey, I can do all this visualization, but if I have a guy sitting on a computer doing searches 24/7, it's going to be a lot more expensive than using another monitoring tool. So what I'm going to do now is go ahead and look at some of the daemon changes. So I'm going to go back to the home screen, go into change tracking again. And I've been noticing a lot of service changes in this where, hey, I jump into a box and all of a sudden the service has stopped. So I want to be notified if that ever changes. So I'm going to go ahead and click into the On Hagoop Twitter piece. And it says, oh, hey, look, the service state is now dead. So that's not something I want. So what I'll do is I'll click alert. And now I'm going to say, hey, the service is dead. Give a description of service is dead. And give myself an email, hey, the service is dead. And I can also do this check real time. I can do it every 15 minutes. Maybe this is a 10-minute job, and I want to see if the 10-minute job took longer than that, if it took less than that. It's all using the query language. So if you can query it, you can alert on it. And what this allows me to do is really monitor at both the config level, the update level, at the OS metric level, if I want to do an aggregated alert across all of these, I have a HPC cluster that's doing jobs for deep neural networks, and it has 1,000 nodes, and if the CPU ever runs 50% across all of these nodes, that's when I want to alert. I don't care if one of these nodes is at 100%. I care at an aggregated level. That's really the power where this alerting comes into play, where you can do things like take those aggregations and then alert off that specific metric. And then where do you get the alert? Email is great, but we all have our own special tools. We have these special alerting mechanisms. And we can use these things like webhooks to send it to our own tools like PagerDuty, Slack. We have integration now with ServiceNow and Province that can actually open up a ticket for this. And then lastly, if I want to run a runbook, if I want to remediate on this issue, I can go ahead and do that and say, hey, go and run this SSH script that will go and fix this specific issue if the service isn't running. Go run that. So having all of that ability to first set the alert on very customized parameters, and then the ability to actually remediate on it is critical. Now jumping into the update insights. We've done a lot of work and a lot of talking with a bunch of customers about Linux patching and the difficulties they face. And there's another really good session later this week that's going to go into a lot more depth, but at a very basic monitoring view. What we do is across all of these different distributions, whether that's SUSE, Red Hat, Ubuntu, we're able to understand off of your repository the patches that are available and the patches, and then taking those available patches and then giving you enhanced augmentation data on top that tell you this is a security update, this is a critical update, etc. And when I do click something, say like a security update, I get a nice overview about how many computers there are, how many of these missing patches there are, and what the age of the update is. So if something just came out like Heartbleed, I could see, hey, this is a very recent update. But looks like I have some very basic OSs here that have never been updated in their life, and they have really old updates. Next, if I click on, say, a specific vendor like Red Hat, I could go in and click on the list view, and you'll see there's this bulletin URL, and it has this nice view associated with it. And if I go ahead and click on that from the search, I don't need the definition of what view means, but I'll go ahead and get straight into that Red Hat customer portal. And what this grants me is I don't have to go looking around that, oh, hey, there's this package, and then go on to Bing or Google and then search that package, then go search all the CVs. I get straight into the bulletin URL, and I get the CVs that are associated with it. And that's really good for making sure if I have any of these security updates, that those people that are monitoring these updates have the ability to instantly go take action on it by getting to this customer portal. So next up is applications. So application monitoring is just a wild field, right? There's so many Linux applications out there. There's so many different ways that you're building legacy applications. You're building out things that are using next generation services. And in the time that this presentation has been going on, there's probably been like 5 or 6 more applications been released. And so one of the big things is first-party support for Linux applications from an OMS monitoring perspective. When you look at Windows workloads like SQL and AD, we give you really rich assessments on those and have the capability to say, hey, we're Microsoft and we know how to build AD, so we know how to monitor AD. Or hey, we've built SQL, so we know how to monitor SQL. But when you go and look at these other open source tools like MySQL and Mongo, these are really backed by an enterprise that's selling on top of it a monitoring experience like MongoDB Operations Manager or MySQL Enterprise Monitor. With all these open source tools, you're then having to switch context between this application-specific monitor and the monitoring tool that's actually going across your infrastructure. And that doesn't let you get the full visibility across the stack. You don't have the ability to see if a MySQL performance issue is actually related due to a say operating system level because someone's doing a backup on the OS. And then You have the next generation Linux applications, right? So you have Cloud Foundry, which is looking at it as a big fabric that's across all of these distinct nodes that you can deploy containerized applications into, as well as Docker containers. So actually at DockerCon last year, Mark Russinovich, our CTO of Azure, showcased our Docker container solution. And where OMS comes into play with that is when you look at containers and the data they produce, it's extremely hard to grasp what's going on inside a container. And because it's really ephemeral, it comes up for, say, a second, it logs to a standard out and standard error port, and then you're kind of left with something, if something failed, you just see that the container is no longer running. And so that's where OMS comes in for these large-scale fabric deployments. You can come in, you can get the visibility on these ephemeral containers, you can get the visibility inside the containers, and you get the visibility on the container host, and then have the ability to act on it in an appropriate manner. And the next bullet is full context monitoring with application dependency monitoring. So how many guys have actually heard of application dependency monitoring? Cool, cool. So half the room, so hopefully the other half of the room will get wowed when we show it. This is really the next step in application monitoring, not just giving you a view about what's going on, but giving you full context, giving you full visibility, and giving you the full ability to act and diagnose on, say, not just one computer, but at a whole service level. So actually, let's go ahead and jump into demos. I was going to put a screenshot for ADM, but then I said, you know, the demo is going to be justice enough. So let's go ahead and switch straight into it. Actually, let's first, let's switch straight into that. So application dependency monitor comes in with both Windows and Linux support. And there's a really big deep dive Friday at 9 a.m. So if you're interested in this, you should definitely go to that session. And they have previews available for folks to try. But it gives you this really good overview of what's going on at the OS and machine level as to what the dependencies are, what's talking to what. It looks at what services are applicable to which processes inside a service. And then it also gives you that full context view I was mentioning. So here I've just gone ahead and clicked on this ADM MySQL server. And it looks like things are going well. It's talking to a bunch of endpoints. But you know, I've noticed my application being really slow, and I wanted to see at what piece this was really failing and what was going on over it. So I see this exclamation mark over this ADM demo app server. So I'm going to go ahead and click into that server and get a whole new view about that. And once I've clicked in, I can once again see all of the services that are talking to the ADM demo app server, as well as this exclamation mark giving me two alerts. One about a failed connection, and the two giving me alerts that are critical. So what I mean by full context in the monitoring aspect is on this sidebar, I can actually go ahead and click onto this bell that shows me the alerts, and I have the whole critical alert information there. What was set? What was the threshold, right? If I just say high CPU and I have no idea who set the high CPU threshold, it could be 0. It could be 1 for a demo, right? So having the ability then to jump straight into log search is available, but I also want to check one more thing. Were there any actual changes in the environment? So that change tracking solution I had showed earlier, you have the ability to relate that with what was going on the server. Were there any service changes? Were there any package updates? Because those are the ones that are really going to cause trouble as your service goes up and down. Lastly, I can look at the exact process that's having the failed connection. And you can see it's a backup.pl. It's built to make sure that this application server is backed up. And he was talking to a server before, and now it looks like, hey, that server is no longer there, and it has a failed connection. So I'm able to really quickly get a view of what's going on, discern about alerts, and discern about what changes might have been on the environment in that same context, and then lastly, be able to start acting on it. Right? I have a failed connection over here. I got to go into the server and make sure that connection, maybe the firewall came in, etc. So this is the public preview, and you can, I highly recommend the 9 a.m. to 10:15 session on Friday. They'll go through a huge deep dive of this at a much more massive scale, and as well as at the booth, the Insight Analytics booth, there's demos of this as well. So then talking about some of the next generation pieces like Cloud Foundry and Docker containers, specifically Cloud Foundry. Cloud Foundry is once again one of those kind of PaaS, IaaS solutions that a lot of companies deploy to do containerized applications. And getting visibility inside of it is actually really hard to do. You have to shoot something over to, say, a single logging tool, and then shoot metrics into another single metric tool, and then you're switching back and forth between these two contexts. With the Cloud Foundry solution that we have in preview today, you get both the metrics and the logs all in one place, and then the ability to do the cross-correlation that I've demonstrated earlier. So here you can see some of the things that we point out. Is a quick view of all the applications and what cluster they're in. And one thing to note here is this is not just one Cloud Foundry deployment. This is actually a Cloud Foundry deployment both on-prem as well as in Azure. And so what this is doing is it's combining those two views into one single view that allows you to then diagnose from both areas of the on-prem and cloud world. I also get quick metrics as to how much CPU %, say, a container is using. And that gives me visibility into things that are aggregated at a whole level. So I understand my full compute rather than just a single point in a distributed layer. Then jumping into the container solution. In fact, we just released a new version of our GA agent, the GA agent plus one, yesterday that allows now the latest version of the Docker 1.12. So if you're using that and haven't been able to onboard to our container solution, highly recommend you go do that. And so once again, with the container solution, these things that are coming up and down, that are ephemeral, that are logging, that are hard to get an inside view of, we're able to plug in natively because we're using that open source. We're using FluentD. Docker supports FluentD as a native logging driver. We're then able to take those logs, bring them up into here, as well as do the metrics on top. And if I click into, say, the failed image that I had before, like, say, Jenkins, I get information like the exit code, the command that was actually run, and the environment variables that were set for that specific container context. And that really lets me do things like replicate this and see if, hey, why did this fail? Why is this going bad? And just like before, if I need to alert on any failed containers, if I have a production container, a dev container, a QA container, I have the ability to alert on that. So it really showcases two big points. Is, hey, we're giving you the full view in the application dependency monitor piece. And the second is we're able to give you point solutions when needed for things that are next generation applications that span multiple layers. So custom data, this is the fun one. This is the live, I need the help of the audience to go ahead and do some of these demos. And the first thing is metrics and logs. What is custom data itself? And for metrics, custom metrics are things that you've already been collecting. It's a script that runs every 5 minutes. It's whatever you want it to be. And we've really doubled down on the metric collection with our OMS agent and introduced the ability to collect metrics from collectd and statsd. So if you're not, how many of you are familiar with collectd? We got a couple folks. Okay, awesome. And statsd? All right, one of the two of the same guys. Awesome. All right, so just quick intro to what collectd and statsd is. So collectd is a daemon, a common Linux daemon that runs periodically and can collect metrics, say, from Postgres or Application Y or Nginx or Apache HTTP server. Has a whole host of things that it can collect metrics from. It can collect GPU temperature, it can collect CPU temperature. It's a commonly used thing that a lot of Linux admins already have enabled in their environments. And all we're asked to do is, hey, take those collectd metrics, point them to a single OMS agent, and we'll start surfacing them up in that same metric pipeline you saw before. Now, statsd is a little more fun in that you actually go into your code, you make sure that, hey, I'm going to enumerate this specific function, and it's going to do whatever I want it to, either the time it took to run this function or the amount of coffee left in a coffee dispenser. It has full versatility. So this is giving you access to things that could exist in an IoT device, can log stuff from this cup right here. In fact, I'll show you a demo of me logging from my phone. And lastly is custom scripts. So a lot of people have built shell scripts, Python scripts, Ruby scripts, whatever language it is. And the monitoring they have today is just running that script periodically every 5 minutes. And we, of course, integrate with that, allow you to bring that data up into OMS, and then have that same visualization and aggregation ability that you had with everything before. Now logs. Now, log is, we have introduced this API, so if you don't even want to use an agent, you can just push stuff straight from your Linux applications, whether it's Python, Ruby, Go, fire up to the API, we'll index it, put it in that same log analytics search. But we also have really good support for existing FluentD plugins. So one of the FluentD plugins that already exists is Twitter, and so I've loaded that up, and my friend over there has tweeted, so hopefully we'll see his tweet, as well as custom log support. So instead of having to set something up on the agent side, I want a portal side experience that I just have a discovery wizard, I type in a path, and all 500 of my Linux machines will start gathering that exact thing. We have that support as well. JSON output, this goes back to the API. We can take any JSON data and index it. So let's step into our first metric demo. So I'm going to switch into our performance. We're going to scope this down quite a bit so we can actually view the real-time data coming in. Switch it down to 6 hours. Let's go over to the StatsD gauge, which is the StatsD metric. Let's go ahead and click into the metrics tab. You can see I tested it out right before the conference started, or right before the session started to make sure it's still working. We'll scope down to an hour. And what you'll see here is some light blue coming in indicating what number is going in, what metrics going in. And now I'm going to go onto my phone, click into the application, and now I need someone to give me a number that's greater than 5. That will look kind of cool when it shows up. Anyone? 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 7. How about 7D? Just so it looks cooler. Is that good? Okay, 7D. I'm going to click enter. Now, what's happening is I've sent that 7D, sent it from StatsD. I've sent it from my application to a StatsD server. That StatsD server is doing aggregations on hundreds and hundreds of metrics. And now he's going and he's sending that over to the OMS agent. The OMS agent is translating that to a performance metric for OMS. And by the time I finish talking, it shows up. And so you can see we really are doing real-time performance monitoring, and we are doing it at scale. So you see the 70 showed up, and this is live streaming with the 10 seconds. I could choose another number, and it would go back down. This is not something I've planned. So you have this flexibility in where that data source exists, whether it's your iPhone, whether it's your server, whether it's inside your actual application, whether it's in C#, whether it's in Java. You can then bring that into our metric pipeline and have that available near real time. And lastly, if I say I wanted to alert on this, 70's too high, I could set alert again. Now for the one with the Twitter data, I've loaded up that FluentD Twitter plugin inside of FluentD. Now what I'll go ahead and do is look into my searches because I have that query typed out. And I'll go ahead and click into that. I think we're scoped into an hour. So let's go ahead and click that. So quite a few folks have. And my friend, what was your name? John Hansen. Is that you right there? Perfect. So you could, once again, stream that data from any source, and you can bring it in, have it show up near real time, have the capability to index it. And if I want to do something like, say, export this to Power BI, I have the ability to do that. And some of my favorite use cases about, hey, why do I care about Twitter data? Or hey, why do I care about these custom metrics? Hey, these are just demos, but for the one use case I've seen of Twitter is when you're running a live website and you need to discern of sentiment of people having anger about a certain website and then relating it back to the operation data where the servers are running and the CPU is spiking. So you have the ability now to do that as well. So that goes over the kind of custom data. I have a call to action as I end up the session and then have some Q&A. Is if you haven't created a log analytics workspace, I highly recommend you do so. Second is you create a Linux VM in Azure. Hey, it could be on-prem, it could be in Azure, it could be in AWS. Third is onboard that Linux virtual machine. It's extremely easy to do so. If it takes more than 20 minutes to do all 3 of these tasks, come to me and say you got a problem because it should never take that long. And then lastly, show the Linux data to your customers, to your folks, to the people who want to see that either from an application side or show the Linux data to yourself. And then you have the ability to ask help anytime. You can email me. My email address is there. And with that, I will showcase the rest of the OMS sessions that show a lot more than the just monitoring, also the action on top. Other than that, I'll be here for a Q&A. Thank you very much. Grab some stickers.